Today's video is going to be about IP addresses, ports, protocols, and firewalls. If you watched the last malware presentation video, then you'll know my format is that I have a title with a bit of a goofier title and an equally goofy caption. These two mean nothing. I just put them there for the heck of it if you want to read them. Otherwise, the format of the video is that I'll be reading the presentation to you so you could listen along like the malware video, but I'd really appreciate it if you watch the video because I have some diagrams and I really want to outline some of these topics. The reason I'm using diagrams is because these topics are a little bit more confusing this time around, and you may have to see these diagrams to sort of help understand the concepts a little bit better, and I highly recommend following along. So, with that said, you might not understand everything in this video today. Because some of this is a little bit more confusing, you may find it harder to follow along, but what I want you to understand is that that does not matter. This is still part of the introduction series, and the whole point of this introduction series is to open your eyes to some of these ideas and not necessarily teach you absolutely everything about them. So with that, just make sure you follow along, and even if you don't understand things, you can listen to it a couple times, or you can just keep following along and wait until we implement these tasks, and then you'll start to understand it. So I'll begin the presentation. What is an IP address? An IP address is the address that your computer uses to send and receive data. Think about your home address. Without it, you'd not be able to receive mail from the post office. So is my IP address the same as my home address? No, of course not. Your home address is the street you live on with a corresponding number, whereas an IP address is a series of numbers separated by decimals. A common example of an IP address is 192.168.1.1. IP addresses look similar to this, and it'll be 4 numbers separated by these decimals. So can two devices have the same IP address? Well, this is a two-part question. Yes and no. You cannot have two devices with the same IP address on the same local area network, or your LAN, but devices on LANs use private IP addresses. When a device on your LAN needs to send traffic to someone on a different network, for example over the internet, your router uses network address translation, which is also referred to as NAT, to translate that address into a public IP address. So this is the first big concept here, private versus public addresses. I'm going to exit the presentation for a second and explain to you the difference. If you open up your command prompt by typing CMD into your Windows box, you can open up the command prompt through there, and then once you open it up, you can come here and type in ipconfig, all one word, ipconfig, and find your local area connection. It might be wireless or it might be an Ethernet adapter, but here you'll find your IP address. Mine is 192.168.1.102. That is my private address. If I wanted to find my public address, I could go to Google and type in what is my IP. I'm not going to do that in the video, but I highly recommend that you do it yourself while following along. So go to Google and type in what is my IP to see the difference between your local, or rather your private and your public address. So here I'm going to outline using a diagram. So here you have a home network and you have a business network. First thing I want to point out is that your router at home, your wireless router, it could be a modem. Some of the newer ISPs hand those out, but your wireless router may also connect to a modem and then go to the internet. So either way, the idea here is that your wireless router or your router at home is connecting to the internet. And the other thing I want to point out is the private address on my router and the public address on my router. Now we see that the private address on the router can also be referred to as the inside address, whereas the public address can also be referred to as the outside address. So that is one idea that I want to get across. It can also be called, the private can also be called inside, and the public can also be called outside. There's two different names for it. Now the public address is assigned to the internet or WAN interface of the router. This right here is my internet interface. It's what connects to the internet. So it's on both sides of this interface right here, the internet or the WAN, the wide area network interface, is what has this actual public address or the outside address assigned to it. So it's assigned right there on both sides. Now, these devices can have the same IP addresses when we're inside the LAN. Look at our laptop right here. It has an address of 192.168.1.50. So does our tablet, but that's on a different LAN. This is our business LAN. This is our home LAN. And the two routers, their private or their inside address on their address inside the LAN is also the same, 192.168.1.1, which is a very common address. So the private addresses can be the same, but the public addresses here are different, and they always have to be different. So you can see here these two devices have different outside or public addresses, and that's the way it has to be. If a device is connected to the internet and it's using a public address, it has to be unique. So they always have to be different. Make sure you're aware of that. So if each device has to be unique, then how many devices, or how do you have multiple devices on the same network get translated with NAT? This is a good question. I'm going to go back to the diagram here for a quick second. I have two devices going through this router that need to be translated with NAT, but they're both going to be translated into this public address. So how can two devices have the same public address? It doesn't work, like I just explained. Well, this is a good question, and I want to explain it a little more. If multiple devices on the same network try to go out or get translated, then they'll be using the same address. So, like I just said, not possible. But by using port address translation, multiple devices can have the same public IP addresses. Port address translation is also called PAT. So we have NAT and PAT. What is the difference between NAT and PAT? When using PAT, a port number is added onto the end of the IP address like this. So we have 64, 101, 8, 59, and then a colon and 80. The number after the colon can be between 1 and 65,535. And that number for right now, just consider it arbitrary. We're not going to discuss this process of how the port gets chosen. But by adding on this port number, the router can determine which device the traffic is destined for, whether it be the PC, laptop, or phone. And the concept of PAT is fairly large, so for right now, I just want you to understand that it exists. So in our diagram, this laptop could be using port 80, and this phone rather could be using port 90. So let's continue on. I just want you to be aware of that. And what exactly are these ports I keep speaking of? I keep referring to ports, but what are they? So there's a reason I didn't talk about it until now. And that's because ports can be used for more than just PAT. Let me begin by saying there are 2 to the power of 16 ports, which is 65,536, and those ports are 0 through 65,535. So instead of 1 to the 36, we go 0 to 35. So the first 1024 ports, which once again I want to point out we're including 0, so it's 0 to 1023, are usually referred to as your reserved, your well-known, or your system ports. A few names for that. But essentially these reserved ports are designated and they have corresponding services or protocols. The most common example is HTTP, or Hypertext Transfer Protocol, and the port associated with it is port 80. And when you're using a device that requests web traffic, it tells the destination device that it wants port 80 or HTTP traffic. That way the receiving end knows to be sending over web traffic instead of some other undesired content. So every time you use your web browser, you type in HTTP followed by the website. What you don't even realize is that you're telling Google.ca that you want its web traffic. You don't want something else. You don't want a different port number. You want port 80. You want HTTP traffic. You want web traffic. There's 2 ways to tell your browser that. You can actually also type in the IP address of Google followed by the colon port 80 to say, this IP address, I want your web traffic. And then that'll bring up the same Google web page. So I recommend you try that just so you see it for yourself. Try entering both of these into your search bar on your browser. So ports and protocols. For right now, I just want you to know the most common types of ports. We're going to implement all this knowledge later on, so for right now, just put these all to memory. You don't necessarily have to know what they do and know everything about them. Just put them to memory. So you may have to pause the video and read this yourself, but I'll just quickly go over it. 21 is File Transfer Protocol, FTP. 22 is Secure Shell and Secure FTP, SSH or SFTP. 23 is Telnet. 25 is Simple Mail Transfer Protocol, SMTP. 53 is Domain Name System, or it could be called Domain Name Server, Domain Name Service. That's DNS. 67 and 68 are Dynamic Host Configuration Protocol, DHCP. 69 is Trivial FTP or TFTP. 80 is Hypertext Transfer Protocol, HTTP. 109 is Post Office Protocol v2, POP2. 110 is Post Office Protocol v3, POP3. 161 is Simple Network Management Protocol or SNMP. 162 is an SNMP trap. 194 is Internet Relay Chat or IRC. 443 is HTTP over TLS or SSL, that's HTTPS. 445 is server message block or SMB. 465 is SMTP over TLS or SSL. 514 is syslog. And 520 is routing information protocol or RIP. So keep in mind these are only some of the common ports. You'll come to know these a lot more better in the future. But for right now, just understand that these are all out there. Try to put some of them to memory so that if somebody asks you what is port 10, you can tell them that it's POP3, even for right now if you don't necessarily know what POP3 does. Firewalls. People always talk about firewalls, but they may not necessarily know what exactly a firewall is. A firewall can be software or hardware. Software being an application or a program on your actual PC or device, or hardware meaning that you actually plug it into the wall and its purpose is to be a firewall. In either form, the goal of the firewall is to control traffic coming in and out of your network. This means you're blocking traffic as well as determining which traffic is allowed to pass in either direction. Keep in mind a firewall can be a multitude of devices, or that rather can be on a multitude of devices. A firewall can be on your router or it can be on your host, and a host refers to any end user device like a PC, laptop, phone. But in either location, it can serve a different purpose and also block different types of traffic. So what kind of what kind of traffic can a firewall block? What are some of the things that it can block? It can block a program, it can block a service, it can block a protocol, a port, whether it's a local or remote port, an IP address. And the IP address, you can have a range of addresses, an entire subnet, or just a single address. And you can block traffic whether it's local or remote traffic. So in this example here, we have this top PC, which is just a PC from the internet. And in this situation, we're going to say this is Jimmy the Jerk, and you don't want him having to do anything with your network. So on your home router here, you can have a firewall on it that says block this IP address. So that way, anytime Jimmy the Jerk tries to access your network, he's immediately blocked at the very front line. By putting it here, we block any attempts at him getting in our network. But let's say we take this bottom PC on the internet, and let's say we want it to be using FTP or port 21, which is file transfer protocol, to access files from our network. Well, we can't just block him at the front, because we need him to access our home PC using FTP. But I don't want him accessing any other port. I want him only accessing port 21, which is FTP. So on my actual home PC, I can say, all right, allow 6278.17, but only when using FTP. So I can make a firewall rule for that on here. So now we've blocked Jimmy the Jerk, but we still have our friend over here being able to access our files. But that means he'd also be able to access the home laptop, and I don't want him accessing my home laptop, so I can set the laptop's firewall to completely block all of his traffic. So as you can see here, by placing the firewall in different locations on different devices and by having multiple firewalls, you can really dictate and specify what kind of traffic is passed around your network and that entire process really. So you have full control over it, and that's the idea here that I'm trying to get across, alright? Is that we have firewalls, and they're going to be incredibly useful, and that's what we'll talk about next video, and we'll put some of this into practice. So based on all that other information I explained to you, I talked about IP addresses, ports, and NAT, and all of that. Now we understand that this is what we're getting into, that our firewalls can block. But if we didn't understand our different services and our different ports, how would we know what kind of traffic we're trying to block? So that's what I was trying to explain, but that'll be the end of this video. And next video, we're actually going to be able to use our firewall and implement some of these tasks on our own.